In today's lesson, we are going to look at differentiation of exponential functions. Differentiation of exponential functions. And an exponential function is a function given in this form, given in the form y equals e power x. That is an exponential function where y is said to be a function of x. And in differentiating these exponential functions, we make use of the chain rule, which we covered some time back in our previous lessons. And then in situations where the exponential function is multiplicative or given as a quotient, where it is multiplicative or given as a quotient, we make use of the product rule. I hope you remember the product rule and quotient rule respectively. So when it is multiplicative, we use the product rule, and when it is in quotient form, we make use of the quotient rule. That is how we are going to learn about this topic when we are looking at differentiation of exponential functions. So we go straight away to example 1, and we are saying differentiate with respect to x the following functions, and we have a, b up to d to go through right there, and we look at the first solution. So part A, we have we can let, to make our life easy, we can say for part A, we can say let y equal to e power x. Now the derivative, say dy dx, will equal to e power x. In other words, here we're having it very clear that the derivative of an exponential function, e power x, gives you e power x. And then part B, we can also continue letting and say it has not been given as y, but we can say let y equal to e power 3x squared. That is part B. And in this case, we shall also let the power here be some other unknown, say u. So let u equal to the power, that is 3x what? Squared. In this case, it means we now have y equal to e power u, where dy du will equal to e power u. And then we have u equal to 3x squared, and du dx here will equal to 6x. And then now we continue to get our dy dx by employing the chain rule. And from the chain rule, dy dx, which we want, will equal to dy du times du dx. And what is our dy du? Our dy du, we allow to put double equal sign, and we may even go to triple because we don't have enough space. We shall have dy du, which is e power u, times du dx, which is 6x. So finally, we get this as 6x of e power u, but remember u is 3x squared. So this becomes our derivative for e power 3x squared. So yes, so part C, we have, we shall say let y equal to e power tan x, and we shall also let u equal to tan x. This will mean that we have y as e power u, and in this case dy du will equal to e power u. Then for u equal to tan x, we shall need du dx, which will equal to sec square x. That will take you back to differentiation of trig functions, and which will give us now from the chain rule, the y, the x, which we want, will now equal to the y, the u, times the u, the x. I will buy some space here, allow me to put double equal sign there. The y du is e power u, and the u dx is sec squared x. That gives us finally that the derivative of e power tan x is equivalent to e power u times sec x, and e power u is the same as e power tan x because u is tan x times sec squared x. Just like that. That is part C. And with those 3 examples, I will leave part D for you to do. And remember, part D was reading e power for x. So can you quickly differentiate this one for me? And then we will continue with other examples, especially in the next category, where we look at those which are multiplicative and those which are appearing as quotients, and we will make use of the quotient and product rules accordingly. Thank you for attending today's lesson. It has been Teacher Okata, Video Learning, Uganda.